Hey guys, so I'm going to teach you how to problem solve with composite figures. By the end of this lesson, you'll be able to solve some real-world problems involving areas of composite figures made up of parallelograms, triangles, and circles. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. All right, so like I've said in the last video, area in real life is not just usually a triangle or a rectangle. A lot of the times, it's often made up of multiple different shapes. That's what we call a composite figure. So let's go ahead and jump right in with problem number one. This is a great example of a real-life problem using area. The side of a barn needs to be painted. Everything, including the barn doors, will be painted. How many gallons of paint are needed to complete the job if a gallon covers 250 square feet? So when you think about paint covering something, that's a question about area. If you didn't know that off the top of your head, square feet is your other clue for area. So let's think about what we know looking at this picture. I know that I can split this shape into two, making a triangle at the top and several rectangles at the bottom. Since we're painting the whole barn, I can find the area of the triangle and then add that with the area of the big rectangle. Starting with the rectangle, I see that it has a base of 30 feet and a height of 20 feet. So I'm going to write that here in the I know box. Looking at the triangle, I see that it shares the same base here with the bottom of the rectangle. So 30 would be the measurement there of the triangle, and the height would be this 8, since that's the length of the top of the tip of the roof to the base here. I also know that 1 gallon of paint covers 250 square feet, but we'll get to that later. And I also know my area formulas for rectangles and triangles. I'm going to start by writing those in the plan and work box, just to give myself a little room here. So we're going to find the area of the whole figure, but what we need to know, what the question is actually asking, is how many gallons of paint are needed to complete the job. So it's really important that you write that down somewhere or underline that in the problem, because whenever you're looking at this, you're going to get caught up in a lot of this work here. At the end, you're going to think that you're done when you have an answer. But let's make sure at the very end we actually answer the question, how many gallons of paint, not just what's the total area of the figure. So let's start by finding the area of the rectangle. I know that the formula for the area of a rectangle is base times height, and I've already identified what the base and height are. So I'm going to plug in those values for the rectangle. I know it's 30 and 20, so now I need to multiply. 30 times 20 is 600. Since I'm talking about area, I need to make sure I put feet squared at the end. Let's do the same thing and plug in our values for the area of the triangle. I know the base and the height for the triangle. I already listed that here, so I'm just going to substitute those in. I know I need to find half of 30 times 8. I can also do half of 8 times 30. That's probably what I'll do because I know that 4 times 30 is 120. Just like the rectangle, I need to put square feet because that's, again, the area. So this is how many square feet I would need to cover both the rectangle and triangle. To find the total area, I need to add. So I know that this whole surface face of the barn is 720 square feet. Now the question is asking about how many gallons of paint I need to use. I know that 1 gallon covers 250 square feet. I need to cover 720. So I'm going to take the 720 total divided by the 250. That's going to tell me how many gallons of paint I need. I got 2.88 gallons. However, I'm not going to go to Home Depot and say, hello, can I get 2.88 gallons of paint? Since there's 720 square feet total here, and each gallon covers 250 square feet, I'm going to use 3 gallons of paint, and I will have some left over. But that is all we have to do for this real-world problem like number one. Number two is another great example of a real-world problem where you would need to use area. However, in this question, you are not going to have a picture given to you. Anytime you have a word problem involving geometry where you're going to have a picture that's being described, I want you to draw that. So as I'm reading this to you in the plan and workbox, I want you to draw this shape. It says a bedroom, and it has the dimensions 14 by 12, and hallway, 8 feet by 3 feet, are getting new wood flooring. So again, take a second, draw the bedroom, it's a 14 by 12, and the hallway, 8 by 3, and just do a rough sketch of that. Using that description, your picture should look something like this. So you know the dimensions, and those are shown here in the photo. But then the wood flooring is priced at $6.20 per square foot. That's the unit rate. Let's go ahead and put that in the I know box. And the question is asking, how much will it cost to add the wood flooring? So the question is not just asking you to find the area of this composite figure. It's asking you to find the area and then figure out how much it will cost in total, knowing that it's $6.20 per 1 square foot. So we are going to start by finding the area of each of these shapes. I have 2 rectangles here, a 14 by 12 rectangle and a 3 by 8 rectangle. So we'll start with the bedroom. I know the formula for area of a rectangle is base times height. The base is 14, the height's 12. So after I do 14 times 12, I know that the area of the bedroom is 168 square feet. Now we need to find the area of the hallway. The formula is the same, base times height. I've got a base of 8 and a height of 3, so I'll plug those into the formula. 8 times 3 is 24 square feet. So the combined area is going to be the sum of the square footage of the bedroom and the hallway for a combined area of 192 square feet. So now I need to look at what I need to know. The question is asking for the cost of the wood flooring, not the total square footage, the cost. The cost is $6.20 per square foot. So here's the question I always get. How do I know if I need to multiply this or divide this? I would challenge you to think about this like it's a proportion to answer that question. When you set this up like a proportion, you know that it's $6.20 per 1 foot. So you set up an equivalent fraction over to the right, where square feet is on the bottom. The total we need is 192. So when you look at it like this, you're going to cross multiply to find your missing value. So we are going to multiply 192 times 620. You also know that this is going to be a bigger number. If you divided, you would get a small number. But if it's actually 620 per 1 square foot and there's 192 total, you're going to multiply because that's going to tell you how much money total you're going to be spending. When you do that, your solution will be $1,190.40. So we'll write that in a sentence. It will cost $1,190.40 for the bedroom and hallway flooring. This is a great real life question. My parents just got new flooring in their house, and they needed to know how to do this math so they would know how much money they were going to have to spend and budget for and how much money they could save if they went with one plan versus another. So this is really, really good real life information here with the painting example and this flooring example. Number 3 is very similar to 1 and 2, so I'm actually going to skip number 3. The only difference with this one is that since it's asking about covering everything but the door, you're going to do some subtracting instead of some adding. But let's actually skip down to number 4. And again, if you want to do number 3 and you want to check that with me, you can send that to me or show me, and I would love to go through that with you with the answer. But I want to go over number 4 for sure, and this will be the last one we go over. This one says, Coach Nichols asked the track team to run a lap around the track. Determine the distance the team ran and use 3 per pi. So the one thing we want to note is that this is not a perfect circle shape. This is an oval shape. And actually, if you want to look at it, it's kind of made up of 2 semicircles like this. It's got a half circle here and a half circle here, and then a rectangle here. So I know that the track is made up of a circle and a rectangle. What I need to know is the distance around this composite figure. The distance around a shape is always going to be the perimeter. But since they're circles, we're going to be thinking about perimeter in terms of circumference. So let's actually start with the circumference of a circle formula, since that's probably the most difficult part of this problem. The formula for circumference of a circle is diameter times pi. Using the picture and the fact that they told me to use 3 for pi, I'm going to substitute my values. I'm using 50 meters because that's the distance across. That's the diameter. 3 is what we're going to use for pi today. Then I just multiply to find the circumference. 50 times 3 is 150. Here's the deal. This right here is half of a circle. I used the formula for circumference of a whole circle. However, 2 halves make a whole. So I found the circumference of this, and that's going to be the same as the circumference of this. So I don't need to divide by 2 and then multiply by 2. That will be redundant. I'm just going to leave it as 150 meters because that is the distance around both of these circles. Let's move on to the rectangle. Usually when we find perimeter, especially with rectangles, we would add up the lengths and both widths. However, in this case, I'm just running around the track. I'm not running here and here. So I don't need to find the perimeter of these 50s. I only need to add up this 100 and this 100 because that's the distance around the track. So 100 plus 100 is 200, and that would be all that I'm covering with the rectangle. After adding that up, I can see that I've totally colored this in, so that's the distance all the way around this shape. 150 plus 200 meters gives me a distance around the track of approximately 350 meters. And again, it's approximate because we had to approximate 3 for pi. All right, guys, that's it. If you made it to the end of this video, please comment, what's your favorite paint color? Mine is a light steel looking blue. It's a beautiful color. I paint everything with it. Today, we learned how to problem solve using composite figures and real world examples. So now you should be able to solve those kind of problems involving area of shapes like parallelograms, triangles, and circles. So now you're going to go back to the calendar, include any other assignments you have left for the day. Let me know if you have any questions. Bye.